happy to welcome you all to my channel with the best wishes. We consider application of determinant in the form A, B, C, D. Now this is called a determinant of order 2. There are two rows. Now this is row, and this is column. So we see there are two rows and two columns. So we say it is of order 2. Now the value of this determinant, the definition, we multiply the principal diagonal elements A into D and the other diagonal elements B into C, and the value of this is A into D minus B into C. So it is the rule for a second order determinant. Multiply the elements of the principal diagonal, multiply the elements of the other diagonal, and subtract the latter from the first. Now we consider the application of determinant in doing the problem of area of a triangle with the vertices 3, 7, minus 3, 2 and 4, minus 1. We write 3, 7, minus 3, 2, 4, minus 1. Now you take this determinant, it is 3 into 2, 6, minus 21. So the value is 6 minus 21, it is 27. Now we consider the second determinant. It is minus 3 into minus 1 is 3, 4 into 2 is 8. The value of this is 3 minus 8. It is minus of 5. Now we see there are only two entries. So we bring forth 3, 7 once more and we take the other determinant. 4 into 7 is 28. Then 3 into minus 1 is minus 3. 28 minus 3. 28 minus 3 is 31. Now when you add these fellows, 27 minus 5 plus 31. You will see 27 take away 5 is 22. 22 plus 31 is 53. And the area, for area, that half is a factor always. Half into 53, or it is 63.5 square units. So we get the same answer by the formula method, then the shortcut method of shifting the origin, and then the shortcut method of determinants. Now this method is wonderful because it can be applied in the area of a quadrilateral, in the area of a pentagon, and so on. Okay. Question number 4. 5k if 7, 1 minus 3, 3, 5k are collinear. So there are 3.71 minus 3, 3 and then 5k. They are collinear. Choices 0, minus 7, 7, 5, none of this. Now we apply short methods. 7, 1 minus 3, 3, 5k. Now take minus 7 for x. Take minus 7 for x. Minus 7 for x. Take minus 1 for y. Minus 1 for y. Minus 1 for y. So you observe here 0, 0 is coming. Minus 7 minus 3 is minus 10. 3 minus 1 is 2. And minus 7 plus 5 is minus 2. And k minus 1 is k minus 1. You multiply these two fellows. You multiply these two fellows. So product is minus 10 into k minus 10k minus 10 into k. Minus 10 into minus 1 is plus 10. Then minus 2 into minus 2 is minus 4. So net effect is minus 10k plus 14. Now this is the area of the triangle. Now what happens if the points are collinear? If the points are collinear, you see there is no triangle. A triangle, 3 vertices, and if this vertex comes over here, the triangle is not there. Area is 0. So we see this is a 0. So collinear means area 0, and that gives you the value of k. Minus 10k plus 14 is 0, or you say 10k is 14, or k you can divide by 2, 7 by 5. And the question is, what is 5k? So 5k is 7 is the answer for the question. So the choice is C. Okay. Number 5 question. Area of the quadrilateral with vertices 4, 1, 1, 4, minus 3, 4, and minus 4, minus 4. Taken in order. So A, B, C, D. A, B, C, D. Now we work out using determinants. 4, 1, 1, 4, minus 3, 4, minus 4, minus 4. You know that we had to repeat 4, 1. Now we start taking the first two. 4, 1, 1, 4. 4 into 4 is 16. 1 into 1 is 1. 16 minus 1 is 15. We go for the second determinant. 1 into 4 is 4. Then minus 12. 4 minus minus 12 is 16. 4 plus 6, 12. Next is minus 3 into minus 4 is 12. Minus 4 into 4 is minus 16. So 12 minus minus 16. 12 plus 16 is 28. And then finally, minus 4 into 1 is minus 4. Then minus 16. So it is plus 16 minus 4. It is 12. Now we add these fellows and you divide by 2. The area comes. So area will be half of 16 is 8, plus half of 28 is 14, plus half of 12 is 6, plus 7.5, half of 15. And you see the answer comes 20, 28 plus 7, 35.5 square units. This is the area of the quadrilateral. Now here we are not shifting the quadrilateral into two triangles and then getting the area. This is a short method using determinants. Now we consider area of the pentagon with the vertices 3, 1, 1, 7, minus 3, 5, minus 7, 1, and minus 3, minus 3. As before, we apply determinants. 3, 1, 1, 7, minus 3, 5, minus 7, 1, minus 3, minus 3. We repeat 3, 1. Now, the first determinant, 21, 3 into 7, minus 1 is a 20. The second, 5 into 1 is 5, minus 21, 5 plus 21 is 26. The third one, minus 3 into 1, minus 3, minus 35. 35 minus 3 is 32. The next one, minus 7 into minus 3 is 21. Minus 3, 21 plus 3 is 24. And finally, minus 3 into 1 is minus 3. Then minus 9. So 9 minus 3 is 6. And area is half the sum of these. So we see the area comes there. So actually this is 20, half is 10, plus 13, plus 16, plus 12, plus 3. It can be worked. We now consider the next section in geometry. It is straight line. Now we move to the slope of the straight line, equation of the straight line, and so on. Y in the xy plane. We see O is the origin. OX, OY are the axes. We have PXY. We drop a perpendicular PM. Now OM is X, PF is Y. This angle is theta. We call it as theta. Now tangent of theta, or it is tan of theta, is the opposite side divided by adjacent side in a right triangle. So we require a right triangle. Theta is here. This is the opposite side. This is the adjacent side. Now the side opposite to the right angle is called the hypotenuse. So we require opposite side by adjacent side for tan theta. So here tan theta is y divided by x. The name for tan theta in this case is slope of OP. So this is a fundamental idea. Slope of OP is y divided by x. Now if you consider a point P, adjacent point Q, suppose this is P, X, Y, and Q is the adjacent point X plus delta X, Y plus delta Y. So we see theta is coming here. This is height Y, this is height Y plus delta Y. So this is delta Y. This is width x plus delta x. This is x. So this is delta x. We observe slope in this case is delta y by delta x. And that becomes dy by dx in calculus. Fundamentally, slope is height divided by base of, we consider A 5.2, B 7.9. We go for slope of AB and we write as MAB. M stands for slope. It is height by base. 2 to 9. So 9 minus 2, 7. This 7 is 9 minus 2 by base 7 minus 5. 9 minus 2 is 7. 7 minus 5 is 2. So is the slope. So slope of AB is actually y difference divided by x difference. This is our M. But remember, this difference is taken in order. That means if 9 minus 2 is taken, we have to take 7 minus 5. If 2 minus 9 is taken, we have to take 5 minus 7. And the result will be exactly minus 7 by minus 2, or it is 7 by 2. So slope m is y difference by x difference in order. Now here we discuss a situation. A is the point x1, y1. B is the point xy. B is the point x2, y2. They are on a straight line. Now what is the condition that you are getting? If you draw perpendiculars to the x-axis and then perpendiculars from A and B, you get two similar triangles. These triangles are similar and we see theta is coming the same thing. So slope of this is tan theta. Here slope of that is again tan theta. So it is the same straight line. So we see slope of the line slope of the whole line m is y difference by x difference, or y difference by x difference, or y difference by x difference. So we see here y difference is y minus y1 by x minus x1. It is the same as y2 minus y by x2 minus x. It is the same as y2 minus y1 by x2 minus x1. So this is a fundamental result. It can be applied in the equations x and so on. So this is a basic idea, slope of a line. Now if A, P and B are collinear, we see this is the situation. Now if A, P, B are not collinear, you are not getting this situation. So in the case of collinearity, we can apply this result.